This we had covered. Yes. So smaller the area over which the force acts, larger is the pressure exerted. Means if we have smaller area, then more pressure will be felt. More pressure would be felt. And if we increase the area, then there will be less pressure. Okay. So if we increase the area, then there will be, if we
Then
increase the
there
area,
will
there will
be
be less pressure for the same force. And if we
yeah.
increase the area, then there will be more pressure for the same force. So smaller the area over which the force acts, larger is the pressure exerted, and larger the area over which the force acts, smaller is the pressure exerted. Because pressure and area, they are inversely proportional. They are inversely related. If we decrease the area, then pressure will increase. And if we increase the area, then pressure will decrease for the same force. We are keeping the force same and we are changing the area, then pressure will also change accordingly. Okay.
Yes.
So now we have questions related to this. School bags have broad straps. Why school bags have broad straps? What is the reason of school bags that they can have broad straps?
Uh, like
Because
uh,
broad straps increases the area of contact.
yes.
Broad straps increases the area of contact, and because area of contact is greater, so less pressure.
Yeah. And ma'am, if we will have a like we will if we will not have broad straps, then uh, the all of force like the bag is heavy, so it can like hurt or like
Yes,
that.
can hurt
We
us.
can
Hmm. So larger the area over which the force acts, smaller is the pressure exerted. Okay, because with broad straps, area of contact increases. And because area of contact increases, so there is less pressure on shoulders.
okay.
Next, nails have sharp points.
So that we can if we need to put in a wall or anywhere,
Yes,
we
because
can
they have small area, we can easily, bolo,
easily push or like
press it.
we can put force on them.
Yes, because they have smaller area, so more pressure will be exerted.
Yes.
Knives and cutting tools have sharp edges.
Sharp edges. Uh, Knives and cutting tools. uh, Sharp edges. So that if we need to cut
We
something
can,
hard, we
we can
can
cut
cut
easily
uh,
by
easily
applying
with the
small force. More pressure will be
small.
exerted on the thing, and we can cut it very easily. But if the knife is blunt, then in that case, it is difficult to cut the vegetables and fruits and any other thing, right?
Yes.
Again, the same reason, smaller the area over which the force acts, larger is the pressure exerted because
Yes.
we decrease the area to increase the pressure. Okay,
Yes.
next question. Porters wear turbans on their head. While carrying the load, porters wear turbans on their head. Why?
Yes. So that the weight
Hmm.
it can distribute.
Yes. And we, by putting turbans, by wearing turbans, we increase the area of contact.
Yes.
Area of contact is increased and there is less pressure. With more area, we have less pressure. Next, tanks move on caterpillar tracks. Have you seen army tanks?
Yes.
They have so many wheels and a belt, right?
Yes.
Hmm.
uh, uh, tanks move on caterpillar tracks. What
They
like
have
what the
caterpillar tracks because they are very heavy.
okay? So tires can't uh
Tires can't hold pressure,
tires can't load their weight.
hold their weight. Yes, tires can't hold their weight, and they are very heavy. And uh, when we have caterpillar tracks, then we increase the area of contact, and weight is again distributed,
Yes.
and we feel less pressure. Less pressure is felt. Okay, we increase the area again. Pressure is smaller for large area. It is difficult to walk with high pencil heels. Why is it difficult to walk?
Because
Why do you find difficulty in walking?
because it's like very thin
Hmm. Area of contact
and
is very small.
all forces uh, all forces on that heel,
On
that
that
pencil.
small area only.
Yes.
So more pressure is felt. Again, smaller the area over which the force acts, larger is the pressure exerted.
Yes.
Now we have numerical problems based on pressure. So what is the formula of finding pressure? How do we find pressure?
Pressure uh, uh, pressure is p Pascal.
That's the unit.
Okay, a force by area.
Yes, pressure is force upon area. So formula used is pressure is equal to force upon area. We'll be using this formula only. Pressure is measured in Pascal and also in Newton per meter square. Unit of
Yes.
force is Newton, area is meter square, and unit of pressure is either we can write Newton per meter square or we can write Pascal. That's our choice. Okay.
Okay.
Now, see, when we deal with area, then we can get area in different units. We
Hmm.
can get area in meter square or centimeter square. And if we have area in centimeter square, then we have to convert that centimeter square into meter square,
Yes.
right? Because meter square is the SI unit of area, na?
Yes.
So we always want our area in meter square. For this, we have this conversion relation. In 1 meter, we have 100 centimeter. So if we square both the sides, look at the cursor. If we square this 1 meter and this 100 also and this centimeter as well, then when we square this 1 meter, we get 1 meter square. When we square this 100, then we get 10,000.
Okay.
100 multiplied by 100 is 10,000. And centimeter
10,000
square, okay, when we square the
centimeters.
centimeter, we get centimeter square. So
Hmm.
1 meter, if 1 meter is 100 centimeter, then 1 meter square will be 10,000
10,000 centimeter
centimeter
square.
square. We can write like this as well. Because 1 meter is 100 centimeter, then 1 centimeter will be, look at this, 1 meter is 100 centimeter. So 1 centimeter is, this 100 is multiplied by this, na? So we'll take this 100 there. We can move this 100 from here to there.
Yes.
Then 1 centimeter will be 1 upon 100 meter.
Hmm.
In the same way, we can write for centimeter square.
Yes.
So 1 centimeter square is, move this 10,000,
1 by 10,000 centimeter square.
1 by 10,000 meter square.
Meter square.
1 by 10,000 meters square. Okay. This is how we convert meter square into centimeter square and centimeter square into meter square. So if we have area in meter square and we need area in centimeter square, then we multiply it by 10,000. And if we have area in centimeter square and we want our area in meter square, then we simply divide it by 10,000. Do you want to write this?
Yes.
Please write. A force of 10 Newton acts over an area of 10 meters square, calculate the pressure exerted. We have a force is given to us. It is 10 newtons. Area is also given. It is 10 meters square. We have to calculate the pressure exerted. How do we find the pressure?
Force by area.
It's force upon area. So force is given. First, we'll write the things which are given to us. So force is given and area is given. Okay. Force is 10 newtons and area is 10 meters square. Then we'll write the thing that we have to find out. We have to find the pressure exerted. And how do we find pressure? Pressure is force upon area. So we'll simply put the values here. Force is 10. Area is also 10. So 10 upon 10 is 1. So answer is 1 Newton per meter square. Okay, easy? Next question.
A force of 100 Newton acts over an area of 40 meters square. Calculate the pressure exerted.
A force of 100 Newton acts over an area of 40 meters square. Calculate the pressure exerted. So force is given and area is given. We have to find the pressure.
Yes.
How do you find the pressure?
Force by area.
Force by area.
100 Newton by 40 meters square.
What will you get by dividing these two?
10 by 4.
10 by 4,
Wait.
simplify the fraction now.
4, 4, 2, 4, 5 by 4.
10 by 4, 5 by 2.
5 by 2. 5 by 2.
Yes. And 5 by 2 is
Or
2.5 Newton per meter square. Yes. Pressure is force upon area. We'll put the value of F and A here and we'll get our answer. Easy?
Yes.
Next question.
A force of 60 Newton acts over an area of 30 meters square. Calculate the pressure exerted. Force is 60 Newton. 60 by 30.
Yes.
2.
60 by 30 is 2. So first we'll write the things which are given. Force is given and area is given,
Yes.
and we will write the solution. Always write the formula first. First write the formula and then put the values and get the answer. And don't forget to write units also. Unit,
Okay.
your marks can be deducted. If you don't write the units, your marks will be deducted. It is mandatory to write the units every time you're doing the numerical problems. Okay?
Okay.
So force is 60 and area is 30. So 60 by 30 is 2 Newton per meter square. Easy. Next question.
A force of 50 Newton acts over an area of 0.1 meter square. Calculate the pressure exerted.
You can solve this in your notebook. Huh?
Okay.
Force and area is given. We have to find the pressure. Pressure is force upon area. Put the values and get the answer.
50.0.1. We need to 0.1 we can write as 1 and multiply by 10 we can write.
Okay, what is the final answer?
50 by 1 multiply by 10. 50 by 1. 10.
Write the solution in the notebook.
Okay.
50 by 0.1. Yes, now tell me the answer.
5
Is it 5?
or 5.
Check your answer.
50 by 0. Okay. Okay. I did it 50 by 0.1 and multiply by 10. I didn't multiply by 50.
Okay. So answer is now correct the answer. 500 Newton per meter square. This 0.1 we can write as 1 by 10 and this 10 goes to the numerator
50.
to 50.
Yes.
Yes. Next question. Should I move to the next question?
500. Yes. calculate the pressure exerted by the force. Area is given. Okay. 60 is force and area is 30. Pressure is 2. No, 30 centimeters square, na? So, centimeter square, 1 centimeter square.
First, we'll convert this centimeter square into meter square, and then we'll divide.
Yes. Hmm.
So,
Uh,
newtons, area
force
is 30 centimeters square. How do we convert centimeter square to meter square?
centimeter square, 1 centimeter is equals to 1 by 100 centimeter and
1 centimeter is 1 by 100 meter.
meter, and
1
30
centimeter
centimeter
square is,
square will be thir 1 by 30 meter.
please write what you had written earlier. How do we convert? See, in 1 meter square, we have 10,000 centimeter square.
Yes.
So, in 1 centimeter
30,
square,
60, no, 30 into 30. So 30,
no, Lavansh, in 1 meter square, we have 10,000 centimeter square, right?
yes.
So 1 centimeter square is 1 upon 10,000 meter square. So we need to divide this 30 by 10,000.
Okay. 30 by 10,000. Okay.
Yes.
Hmm.
If it is not clear, I can elaborate this.
Now it's clear.
It's clear.
30 by, yes.
In 1 centimeter
Okay,
square, we have 1 upon 10,000 meter square.
yes.
You
And
had written in,
here we have 30 centimeter square. So,
it's 3 upon
uh,
1,000 we can write now.
hmm,
Now we will write the solution. See, pressure is force upon area. Now put the values because area is in the denominator. Area is in the denominator. So when you divide, this 1,000 goes to the numerator and 3
yes.
remains in the denominator.
Hmm.
What do we get? We get the pressure as,
20,000 Newton meter square.
yes, 20,000 Newton per meter square. Write the solution in your notebook.
Okay.
Now read this question.
A force of 400 Newton is exerted over an area of 160 centimeter square. So force is given and it's 400 Newton
Mhm.
and area is 160 centimeter.
Square.
Area is 160 by 10,000. So we can cut the zeros.
Yes.
16 by 1,000 meter square.
And then we'll find the pressure by dividing these two.
Yes.
Do it. So force is given, it is 400 newtons. Area is 160 centimeters square. So we can easily convert this into meter square by dividing it with 10,000. So we'll get this 16 by 1,000 meters square. Now we have to find the pressure. So you can simply divide these two to get the pressure, right? Do it. Pressure is this, force upon area, answer is 45,000 Newton per meter square.
5,000
This
Newton
is what you're
square.
getting, right?
Yes.
Next question.
Calculate the pressure exerted by a force of 20 Newton over an area of 20 centimeter into 10 centimeter. 20 into 10 centimeter is 200 centimeter.
Yes, because dimensions are given this time, so we'll just multiply these two to get the area, and area we are getting in is in centimeter square.
Hmm.
So first,
200
we'll convert this into meter square first.
divided by 10,000 is 20, 2 by 100.
Yes, it's 2 by 100 meters square. First, we'll multiply these two. It's 200 centimeters square. And then we
20.
divide this by 10,000 to get the answer in meters square. So it is 2 by 100 meters square. Now find
1000
answer is
1000.
answer is 1000 Newton per meter square. Correct answer. Very good. Very fast. Pressure is force upon area. We'll put the values here and get the answer. Next question. Similar question we are getting here.
Calculate the pressure exerted by the force of 84 Newton over an area of 120 centimeter. No, 1200.
Centimeter. Yes.
1200. 1200 centimeter. 1200
Square.
by
Yeah, don't forget to say square. Centimeter square. Area.
1200 centimeter square divided by 10,000 will be 12 by 100.
Yes. So force is 84 Newton and area is 1200 centimeter
84,
square. Dimensions are given. So we'll divide
84.
this by 10,000 to get it in meter square. So you can also simplify it because we're getting 12 by 100. So we can simplify it because both are multiple of 4. You can see 4 threes are 12 and
Yes.
25 fours are 100, right?
425, sir. Yes. 3 by 25.
Yes, 3 by 25 meter square. What is the value of pressure we're getting?
Wait. 3. 700.
Yes, very good. 700 Newton per meter square is the correct answer. Always say 700, no, not 700. 700 is a
Newton.
number. You are giving me the
7.
answer of pressure, na? You're getting the pressure. So pressure is 700 Newton per meter square. With units, you should answer the question. Okay, if you have area, mention the unit, meter square or centimeter square. If you have found out the value of pressure, then say 700 Newton per meter square, ma'am. This is how you should speak. If you say 700, then it becomes your habit. And you can forget to write this unit. You can forget the unit, right?
Yes.
Next question. We have a cuboid. Dimensions are given. It is lying on a, is it lying? It is lying on a table. Calculate the maximum pressure exerted by the cuboid. Okay. Our
It
cuboid of
is
dimensions this
more
is lying on a table. Calculate the maximum pressure exerted by the cuboid if the force applied is 100 Newton. See, we need to find the maximum pressure. For maximum pressure, area should be
area meter square.
area is in meter square, but if we want maximum pressure, then area should be minimum, na?
Yes.
So we have a
Yes.
cuboid. Cuboid is three-dimensional, right? Cuboid has three dimensions. It has length, breadth, and height. And it is lying on the table. Suppose, let me take something. I have this AC remote in my hand, and if I keep this remote on my hand like this, you can see the area of contact. The area of contact
Yes.
is this rectangle. And if I place the remote on my hand like this, then area of contact is smaller,
Yes.
right? In this case, area of contact is smaller. If I place remote on my hand like this, again, the area of contact
It's smaller. Like
Where do we get the smallest area? See, if I place this remote like this, do we get smallest area? Or like this or like this? How
like
should I place
this.
the remote?
By like this.
Vertical position. In
Yes.
this
In
position, we are getting the smaller area of smallest area of contact.
yes.
This is medium, and this is the maximum area that we'll be getting.
Yes.
Right? This is the maximum area will be maximum area of contact, and this lies within both both the different other cases, and this is the minimum area we'll be getting. The maximum area is this, and minimum area is this. So we have to place the cuboid on the table in such a way that we feel maximum pressure on the table. For the pressure to be maximum, area of contact should be
Maximum.
minimum. Minimum, because pressure and area, they are inversely related. If you want pressure to be maximum, then area should be minimum.
Okay.
Okay. And we have, suppose, let's assume that this is a cuboid. Okay. So this is 5 meters. The longest one is 5
Yes.
meters. And this one is 4 meters.
Hmm.
And the thickness is 2 meters.
Okay.
So when we place this remote on the hand like this, area of contact is the maximum. Maximum
Maximum.
area of contact is there, right? So we have 5 and 4. We have 5 and 4. See, if I draw, if I
Yes.
outline this, if I outline this, then a rectangle will be formed on my hand,
Yes.
and dimensions of rectangle will be 5 and 4, right?
Yes.
But if I place this remote on my hand like this, and we outline this remote, please look at the screen. If
Yes.
we outline this remote, now the dimensions of the rectangle so formed on my hand will be 4
Will be
cross 2
minimum.
minimum. So it's 4. This is 4, no? And this thickness is
Yes.
4 cross 2.
2.
So we need to put the cuboid on the table in this position to get maximum area. To get maximum pressure. Okay? We need to put the cuboid on the table in this position, because in this position area is the minimum and therefore pressure is the maximum. Okay? So what dimensions we should take to get minimum area?
4,
4 and
5, 4 and 2.
4 and 2. Yes. So dimensions of cuboid is given, force is given, and we have to find the maximum pressure exerted. For maximum pressure,
Minimum area.
minimum
That
area,
is 4 meter and 2 meter.
yes, minimum area will take, because smaller the area over which the force acts, larger is the pressure exerted. If you want pressure to be maximum, then area should be minimum. They are inversely related. Okay, we'll find the area by choosing these two dimensions, this 4 and this 2, because in this case, when we choose these two, we get the minimum area. If we choose this 5 and 2, then what area you'll get?
10.
10. And
10.
if we choose
And
this 4 and 5,
5, 20.
get 20. Here we get 20, and if we choose 5 and 2, we get 10. When we choose 4 and 2, we get 8. 8 meters square is the minimum area we are getting.
Yes.
Right? And pressure is force
Yes.
upon area. Force is given, it is 100 Newton. Area is also, we have found out. It is 8 meters square. You simply divide these two and you'll get your pressure in Newton per meter square.
Yes. Okay.
Easy? Now write this in your notebook. Please read the question.
what will be the effect on pressure if the area is doubled, keeping the force constant?
Area is doubled and we are keeping the force constant. So we have kept the force constant and we have increased the area, right? So what will be the effect on pressure? We are keeping the force constant and we are increasing the area. So when area is increased, then pressure will,
Pressure is less.
yes, pressure will decrease. Okay, so how will we do this? See, first, we know that pressure is force upon area.
Yes.
Yes. So now we are increasing the area and we are keeping the force constant. So the new area is doubled, na? Area is
Yes.
doubled. So new area can be written as twice of previous area.
Hmm.
So we are denoting this new area by A dash and previous area we had was A, right? So
Hmm.
when we double it, if the area is doubled, we can write this as 2A. So this new area A dash is 2A. Okay. Now because area, we have changed the area. So pressure will also change because they are related. They are inversely related. So pressure will also change. So we'll get the new pressure also.
Okay.
For different area, we have different pressure, right?
Hmm.
So the new pressure is previous force because we are not changing the force now.
Yes.
We'll keep this F only.
Hmm.
Only pressure and area will change. So the new pressure is P dash and new area is A dash.
Hmm.
And there is no change in F. We're keeping it as it is. The same. Okay. Now we'll
Yes.
simply write for A dash. We can write 2A
Two-way. Okay.
because A dash is 2A. Na?
Hmm.
New area is twice of previous area. And this F upon A is P.
Two-way.
No, this F upon A. Forget this 2. This F upon A. Consider these two only. This F upon A is
P.
P. For this F
Okay.
upon A, we can write P.
Yes.
And then this F upon A is P. And we have this 2 left. So we can write P upon 2.
Yes. P up. Yes. P upon two. Here it's